A single step, one contraction of the quadriceps, one push from the calf, one swing of the arm. A movement so automatic you stopped thinking about it before your third birthday. In the next 30 minutes of walking, your brain will release a cascade of neurochemicals that no pharmaceutical company has successfully replicated in a single pill. Your hippocampus will begin growing new neurons. Your prefrontal cortex will come back online after hours of stress-induced suppression. Your vagus nerve will shift your entire nervous system out of threat mode. Your body temperature will rise and fall in a pattern that signals your brain that the danger is over. All of this from putting one foot in front of the other on a patch of ground. Your grandmother knew all of this. She said it differently. Go for a walk. You will feel better. Clear your head. You cannot think straight sitting in that chair all day. She did not need a randomized controlled trial to observe what happened to people who moved versus people who stayed still. The evidence was in front of her every day. The loss happened gradually. The car replaced the walk to the shop. The elevator replaced the stairs. The desk replaced the field. The screen replaced the errand. And every year spent more sedentary, the neurochemical deficit deepened in the hippocampus, in the prefrontal cortex, in the amygdala, in the bloodstream, in the gut. Here is the neuroscience. When you begin walking at a moderate pace, your muscles contract rhythmically and bilaterally, meaning both sides of your body are activating in an alternating pattern. This bilateral rhythmic movement is not incidental to what walking does to your brain. It is the mechanism. The left-right alternating activation travels up through your spinal cord and stimulates the brainstem in a pattern that neuroscientists now recognize as directly analogous to what happens during REM sleep, the phase of sleep associated with emotional memory processing. Your brain, during a 30-minute walk, is doing something structurally similar to what it does when it processes and neutralizes the emotional charge of difficult memories at night. This is why things that felt catastrophic before a walk frequently feel manageable after one. The processing is not metaphorical. It is neurological. Within the first 5 minutes, your adrenal glands begin releasing epinephrine and your heart rate climbs. Blood flow to the brain increases by 14 to 20%, a figure measured directly using transcranial Doppler ultrasound in studies at the University of New Mexico. The prefrontal cortex, the region responsible for executive function, emotional regulation, and rational decision-making, is among the first regions to benefit from this increased perfusion. Chronic stress suppresses prefrontal cortex activity and amplifies amygdala reactivity, producing the state in which everything feels threatening, nothing feels solvable, and the emotional brain overwhelms the reasoning brain. Increased cerebral blood flow during walking begins reversing this suppression within minutes. The clarity you feel after a walk is not imagination. It is your prefrontal cortex coming back online with an improved blood supply. At the same time, your brainstem raphe nuclei, the same structures that respond to sunlight through the retina, are activated by the rhythmic movement signal coming up from your legs. These nuclei manufacture serotonin. Peter Kramer at Brown University and subsequent researchers established that rhythmic repetitive movement is one of the most reliable non-pharmacological triggers of serotonin synthesis in the human brain. Every stride is a signal to the raphe nuclei. More strides mean more serotonin. The most widely prescribed class of antidepressants in the world, selective serotonin reuptake inhibitors, works by preventing the removal of serotonin from the synaptic cleft, effectively making available serotonin last longer. Walking increases the supply. The drugs slow the removal. Both raise effective serotonin levels through completely different mechanisms, and the research comparing them directly is striking in ways most physicians never discuss with their patients. James Blumenthal at Duke University conducted what remains one of the most cited studies in psychiatric medicine. He divided clinically depressed patients into 3 groups. One group received sertraline, a standard SSRI antidepressant. One group exercised for 30 minutes 3 times a week at moderate intensity. One group received both. After 16 weeks, all 3 groups showed equivalent reductions in depression scores. The exercise group performed as well as the drug group. But the follow-up data, published 6 months later, revealed the more important finding. Patients in the exercise group were significantly less likely to have relapsed into depression than patients in the drug group. The intervention that produced more durable remission was not the pharmaceutical, it was walking. Blumenthal's explanation was not that the drugs were ineffective, but that the exercise group had acquired something the drug group had not: a behavior, a self-efficacy, a biological adaptation that continued protecting them after the intervention ended. The drug stopped working when they stopped taking it. The neurological changes from exercise persisted because the brain had structurally changed. That structural change is the discovery that reordered everything scientists thought they knew about the adult brain. For most of the 20th century, neuroscience operated under a foundational assumption: the adult brain does not grow new neurons. You were born with all the neurons you would ever have and spent your life slowly losing them. This assumption turned out to be wrong, and the evidence that overturned it came directly from research on movement. Fred Gage at the Salk Institute demonstrated in 1999 that the human hippocampus generates new neurons throughout adult life, a process called adult neurogenesis. The hippocampus is the brain structure most directly involved in memory formation, emotional regulation, and the ability to contextualize experience. It is also the structure most consistently damaged by chronic stress and depression. In people with major depression, hippocampal volume is measurably reduced. The hippocampus physically shrinks under sustained psychological stress. What Gage and subsequent researchers established is that the primary trigger for adult hippocampal neurogenesis is aerobic exercise. Walking stimulates the production of brain-derived neurotrophic factor, BDNF, a protein that acts as a fertilizer for neurons, promoting their growth, survival, and the formation of new synaptic connections. John Rady at Harvard, who wrote the most thorough synthesis of this research in his book Spark, called BDNF Miracle Grow for the brain. 30 minutes of moderate aerobic walking raises BDNF levels measurably in the bloodstream. Consistent walking over weeks and months causes the hippocampus to physically increase in volume. You can grow back what chronic stress has taken from you, and the raw material is a pair of functioning legs and a sidewalk. The stress system tells the other half of this story. Your hypothalamic pituitary adrenal axis, the HPA axis, is your body's primary stress response architecture. When your brain perceives threat, real or imagined, the hypothalamus signals the pituitary, which signals the adrenal glands, which release cortisol. Cortisol is essential in acute doses. It mobilizes energy, sharpens attention, suppresses inflammation temporarily, and prepares the body for physical response. The problem modern humans face is that the HPA axis evolved for threats that ended. The lion either caught you or it didn't. The flood either came or it passed. The stress system was designed for acute activation, followed by resolution. Contemporary psychological stressors, financial pressure, relational conflict, professional uncertainty, social comparison, do not resolve. They persist. And a persistently activated HPA axis means chronically elevated cortisol, which damages hippocampal neurons, suppresses immune function, disrupts sleep architecture, promotes visceral fat accumulation, and drives the cycle of anxiety and depression that characterizes the modern mental health crisis. Walking resolves the stress cycle in the most literal physiological sense. The body's stress response system evolved in a context where psychological threat and physical movement were coupled. The predator appeared and you ran. The physical exertion was the resolution signal. Your cortisol levels dropped, your HPA axis downregulated, your nervous system returned to baseline. When you experience psychological stress without physical movement, you activate the stress response without ever sending the resolution signal. The cortisol stays elevated. The nervous system stays in threat mode. The loop does not close. Walking closes the loop, not metaphorically, mechanistically. The physical exertion tells your HPA axis that whatever the threat was, you have responded to it. Cortisol drops. The nervous system downregulates. The loop closes. Bessel van der Kolk, who spent his career studying how trauma is stored in the body, arrived at the same conclusion from a different direction. The body keeps the score, and the body resolves the score through movement. The vagus nerve runs this resolution through a parallel pathway that researchers are only beginning to fully map. The longest cranial nerve in the body, the vagus runs from the brain stem down through the heart, the lungs, and the gut, carrying signals in both directions. Vagal tone, the strength and regularity of this nerve's signaling, is among the most reliable physiological markers of psychological resilience. High vagal tone is associated with better emotional regulation, faster recovery from stress, lower inflammation, and reduced risk of depression and anxiety disorders. Low vagal tone is associated with the opposite. Walking increases vagal tone through two simultaneous mechanisms. The rhythmic breathing that accompanies moderate walking stimulates vagal afferent fibers in the lungs directly, and the moderate cardiovascular activation of walking, not sprint intensity, but sustainable aerobic effort, produces the heart rate variability pattern that both reflects and strengthens vagal function. Every 30-minute walk is a vagal toning session. The parasympathetic nervous system, the rest and digest counterpart to the fight or flight sympathetic system, is strengthened with every outing. The person who walks daily is not simply burning calories. They are systematically building the neurological infrastructure for emotional resilience. There is a social dimension to walking's effect on mental health that no pill can replicate, and it operates through a mechanism as ancient as the species. Humans evolved as persistence hunters on the African savanna, covering 10 to 20 kilometers per day across open landscapes in small cooperative groups. For the vast majority of human evolutionary history, walking was the primary mode of travel, and travel happened in the company of others. The social bonding that occurred during shared movement was not incidental to human psychology. It was constitutive of it. Neuroimaging studies show that face-to-face conversation during movement activates reward circuitry differently than stationary conversation. The shared rhythm of walking side by side, the parallel rather than face-to-face orientation, which reduces the social threat associated with direct eye contact, the mild physiological arousal that makes conversation feel more alive. These features of walking together were the default context for human social bonding for 100,000 years before anyone sat across a desk from anyone else. When you walk with someone, your footsteps synchronize within minutes, even without deliberate effort. Physiological synchrony of this kind, matched heart rates, matched breathing, matched movement rhythms, is associated with increased feelings of trust, cooperation, and social connection. The loneliness epidemic that correlates so precisely with the decline in physical activity in developed nations is partly a movement deficit. You cannot fully replicate ambulatory human sociality sitting on a sofa or looking at a screen. The dose relationship here is as important as it is in pharmacology, and the research is specific enough to be actionable. A meta-analysis of 49 studies published in JAMA Psychiatry found that 150 minutes per week of moderate intensity walking, which is the equivalent of 30 minutes 5 days a week, at a pace where you can hold a conversation, reduced the risk of developing depression by 26%. This is a population-level effect comparable to the preventive benefit of widely prescribed medications, achieved without side effects, without a prescription, and with documented secondary benefits to cardiovascular health, metabolic function, bone density, cognitive performance, and longevity. Below that threshold, every additional minute still confers measurable benefit. The dose-response curve is steep at the low end. Going from 0 to 10 minutes of walking per day produces neurochemical changes that going from 40 to 50 minutes does not. The most depressed, most sedentary individuals have the most to gain from the smallest initial investment of movement. The first step is disproportionately powerful precisely because the deficit it addresses is so acute. Timing matters too, and the research distinguishes morning walking from walking at other times in ways that parallel the sunlight literature. Morning walking combines the neurochemical effects of movement with the circadian entrainment benefits of morning light exposure. The bilateral rhythmic movement signal that stimulates serotonin synthesis arrives simultaneously with the melanopsin activation from outdoor light that also stimulates serotonin synthesis. The two mechanisms are additive. Morning walkers receive a compounded neurochemical benefit that afternoon gym sessions on indoor equipment cannot replicate. The cortisol morning peak, which functions in healthy individuals as an alerting and energizing signal, is appropriately engaged and then resolved by morning physical activity in a way that sets the hormonal tone for the entire day. People who walk in the morning consistently report better mood, better energy, and better sleep than equivalent distance walkers who exercise later in the day, and the physiological mechanisms underlying that self-report are now well characterized. There is one more thing walking does that connects every mechanism in this account. It changes the relationship between the person and their own mind. Rumination, the repetitive cycling of negative thought that is the cognitive signature of depression and anxiety, is maintained by stillness. The default mode network, the brain's self-referential processing system that activates when external attention is not demanded, is the neural substrate of rumination. Walking suppresses default mode network activity by demanding continuous, low-level attentional engagement with the environment. Navigation, obstacle avoidance, proprioceptive adjustment, social awareness, environmental monitoring. These demands are mild enough to allow conversation and reflection, but sufficient to interrupt the closed loop of self-critical or catastrophizing thought. The ancient Greeks held their philosophical discussions while walking. The Peripatetics, whose name comes from the Greek word for walking about, were not choosing an aesthetic preference. They were accessing a cognitive mode that stillness does not provide. Nietzsche, who suffered debilitating depression and migraines throughout his life, wrote that all truly great thoughts are conceived while walking. He was reporting phenomenology. The neuroscience now has the mechanism. Step back and look at what 30 minutes of walking does to the brain and body you are living in right now. Serotonin synthesis increases in the brainstem raphe nuclei with every bilateral stride. BDNF rises in the bloodstream, stimulating hippocampal neurogenesis and beginning to reverse the structural damage that chronic stress has accumulated. Cortisol drops as the HPA axis receives the movement signal that evolution wired it to interpret as threat resolved. Vagal tone increases, building the parasympathetic infrastructure of emotional resilience. Prefrontal cortex perfusion improves, restoring the rational, regulated, proportionate processing of experience that stress suppresses. The default mode network quiets, interrupting the rumination loop. And if you are walking outside in the morning light, the melanopsin cells in your retina are simultaneously resetting your circadian clock and adding another layer of serotonin synthesis on top of everything the movement is already doing. All of this activated by putting one foot in front of the other. All of it deactivated by staying still. Your grandmother told you to go for a walk when you were sad, when you were angry, when you could not sleep, when you were sick with worry, when you needed to think. She did not know about BDNF or the HPA axis or vagal tone or the default mode network or bilateral rhythmic brainstem activation. She did not need to. She could see what happened to people who moved and what happened to people who stayed in their chairs. She was right. She was always right. The neuroscience just took a few decades to catch up with what she could see with her own eyes. Tomorrow morning, go for a walk. Put one foot in front of the other. The neurochemical cascade that no single pill has ever successfully replicated in full is waiting to begin. Your brain, the brain your grandmother worried about, the brain she sent outside every chance she got, the brain that has been sitting still waiting for the signal it was built to receive, will do the rest.